Hello students, welcome to our YouTube channel Experience Tutor. Today we'll discuss Organic Chemistry Part 2. This video tutorial will be helpful for the students of class 11th, class 12 of CBSE, ICSC or any state board or ISC, or the students who are preparing for IIT, JEE, NEET and any other engineering and medical entrance examination. Before we begin, we have a humble request for you. Please subscribe, like and share our YouTube channel among your friends and relatives. Please click on the bell icon to get automatic notification whenever a new video is uploaded by us. Please click on the like sign and comment on our videos if you like it. Let us start today's class. So today we will discuss dipole moment and molecular polarity. To explain the dipole moment, let us take an example of chloromethane. So if we draw the structure of chloromethane, say this is carbon and say this is chlorine. Chlorine have 7 electrons here, and next is 3 hydrogen. This one hydrogen, this is another hydrogen, and this is the other hydrogen. 3 hydrogen. This is the structure of chlorine atom. So we can see that if we draw the structure of this molecule, if this is the structure of this molecule, then we can see that a partial charge here as delta minus and here as delta plus. And in terms of negativity, since chlorine is negative, more negative, so a arrow which indicates the negativity moves towards chlorine. So in this case, so what is dipole? So what we see here? Here we see two equal and opposite charges are separated by a distance. So here plus delta and minus delta are two equal and opposite charges which is separated by a distance, and which can be denoted as mu is equal to delta, the charge, and length and length. So this is called dipole. It is the indication. What is mu? It is the indication of the negativity. The unit of dipole is given by dB. It is also denoted by D. 1 dB is equal to 10 to the power minus 18 ESU centimeter. This is the relation. Now the next topic is molecular dipole moment. So what is molecular dipole moment? Compounds that have more than one polar bond. For example, in dichloromethane, there are 2 chlorine atoms attached with the central carbon atom, Since chlorine atom is more electronegative, therefore a dipole indicator is towards the chlorine atom, towards both the chlorine atom. So again, let us come to the basic question, that what is molecular dipole moment. So compounds that have more than one polar bond. So here we have two polar bond in dichloromethane. We take the vector sum of the individual dipole moments. The vector sum is called the molecular dipole moment. So in the case of dichloromethane, we will take the vector sum of both the dipole moments, and the vector sum is this one as shown in by the red arrow on the right side. So this is called molecular dipole moment. So basic thing is that if there is more than one polar bond, then we will take the vector sum of the individual dipole moments, and the vector sum will give the molecular dipole moment. This is very straightforward statement for molecular dipole moment. Similarly, we can take few more examples for molecular dipole moment. For example, we can take the example of ammonia. So it can be dipole moments are marked in this way, and even so the sum of the dipole moment or net dipole moment can be marked in this way. Net dipole moment is in this way. Similarly, we can take example of water, that is oxygen here, hydrogen here, here, and lone pairs, lone pair of electrons for oxygen. So if we want to mark the dipole moment, electron is more negative, so it will be arrow will be towards the electron. Similarly, oxygen is more negative, electronegative, therefore arrow will be directed towards oxygen. And the net dipole moment, that is molecular dipole moment of water, is this. So these are the two examples of ammonia and water which shows molecular dipole moment. Let us move to the next topic. Now, based on this molecular dipole moment, we have a question. We have an example. Let us see the problem. Example: identify whether each of the following compound exhibits a molecular dipole moment. If so, indicate the direction of the net molecular dipole moment. A and B. Fine. Let us see what is the solution. Steric number is equal to 4. So let me explain what is steric number. We have done it in the previous class. Those who have not done the previous video class for organic chemistry, please do it, because that is the fundamental. That is the first class. So this is the second class. So let me explain where I have explained the steric number, etc. Let me explain again for those who have not done. So steric number is the addition of the number of sigma bond plus lone pair of electrons. So here the central atom is O. So steric number for O is number of lone pair of electron is 2. So and number of sigma bond for O is 2. 2 plus 2, that is 4. This is the steric number. Remember, whenever the steric number is 4, the hybridization is sp3 hybridization. You have to remember that. And whenever there is a sp3 hybridization, the shape is tetrahedral. These are interlinked. So again repeating, steric, whenever the steric number is 4, the hybridization is sp3 hybridization, and whenever the sp3 it is sp3 hybridization, then the shape is tetrahedral. So we have drawn a tetrahedral shape for the given at molecule. Fine. Now here the lone pair of electron is more electronegative, so we have drawn this dipole here, arrow towards the electron. Again oxygen is more electronegative, therefore we have drawn one dipole from the one carbon atom and other dipole from the other carbon atom towards oxygen atom. These individual, so we have 1, 2, 3, 4 individual dipole moments. So this individual dipole moments, if we do the vector sum, then we get this direction, vector sum. So parallelogram law of vector addition we have done in physics, mathematics. So the direction we can find it out with that concept. We can find it out easily. The direction. So direction is this, as shown is in the figure. So it gives the net molecular dipole moment. So part A we have explained. Now part B. Part B is compound is carbon dioxide. So carbon dioxide, the steric number. Steric number for is 2 here, and hybrid, since remember again, if the steric number is 2, the hybridization is sp hybridization, and when there is sp hybridization, the shape is linear. The shape is linear. Fine. Now how come the steric number 2? So the central atom is a carbon atom. So what I told, that steric number is the addition of the sigma bond and the lone pair of electrons. So how many sigma bonds? So double bond is made up of one sigma bond and one pi bond. So one sigma bond with one oxygen, other sigma bond with other oxygen, so only 2 sigma bonds. So steric number is 2, and hybridization is sp. We have to remember that, and the shape is linear geometry. So dipole, oxygen is more electronegative. One dipole moment for one oxygen directed from towards left, and other dipole moment for other oxygen directed towards right. So they cancels each other. So here molecular dipole moment is 0. No molecular dipole moment. Let us move to the other topic. So this is the test given on this concept of molecular dipole moments. Please pause your video, complete the test. If you have any problem in the test, please write it in the message box that you are having, you can't solve this, or you have some problem in solving this sum. I will explain those sums which you have problem with, but my request is first try it on your own. Thank you. So I am slowly moving the cursor so that you can read the sum and pause the video and do the sum. So here it is important, which is written in red, that whenever you feel that you need some help, please write on the message box of this video that you need a help. We'll help you. We are always 24/7 to help you. So now let us do the next topic. Intermolecular force and physical properties. This is very important property. This is very important topic. So what is intermolecular force? First we have to understand this term. So the physical property of a compound are determined by the attractive forces between the individual atoms, called intermolecular forces. So all the molecules are made up of atoms, and atoms have some forces among them. So those forces are called intermolecular forces, and properties of a compound depends on those intermolecular forces. All intermolecular forces are electrostatic in nature and can be classified as below. So they are electrostatic. Electrostatic means the force due to the charges, opposite charges, equal and opposite charges, or same charges. So force due to the charges. So there can be three types of intermolecular force. First, dipole-dipole interaction. Second, hydrogen bonding. Third, fleeting dipole-dipole interaction. We'll go through each of these forces. So first is dipole-dipole interaction. So compounds with net dipole moments can either attract each other or repel each other. So depending how they approach each other in space. In solid molecules, align themselves so that their dipole moments experience attractive forces. So in solid, molecules are aligned in such a way that they feel a attractive force between themselves. They experience an attractive force between themselves. So they are tightly packed, so they are solid. In liquid phase, the molecules are free to tremble in space, but they are not so much free to move in different far away with each other. Means they do tend to move in such a way so that they attract each other more often than they repel each other. The resulting net attraction force between the molecule results in an elevated melting or boiling point, or melting and boiling points. So this is the characteristics of a liquid in terms of dipole moments. Let us see a solved example. Why acetone has a higher melting point and higher boiling point than isobutane. So for now, just remember this isobutane, acetone, these are some organic compounds. We'll come in the later chapter, we'll go through the nomenclature and we'll tell you what are these compounds. We'll detail study about these compounds. For now, just think that these are two organic compounds. So first, let us draw the structure. So this is isobutane and this is acetone. Question is why acetone has higher melting and higher boiling point. So they are asking why acetone has higher melting and boiling point. Answer is very simple. Isobutane lack a significant dipole moment. So you can see here acetone has a dipole moment, but isobutane do not have a dipole moment. So we are telling that isobutane lack a significant dipole moment, but acetone does have a net dipole moment. Here we are telling dipole moment, that means molecular dipole moment. Therefore, acetone molecule will experience greater attractive interaction than isobutane molecule. As a result, acetone will have higher melting and boiling point than isobutane. Isobutylene, it is isobutylene, not isobutane, it is isobutylene. So remember one thing, that whichever molecule have the dipole moment, its attraction force will be more inside the molecule, and it will have more boiling and melting points. So let us move to the next topic. Next type of force, that is hydrogen bonding. So what is hydrogen bonding? When a hydrogen atom is connected to an electronegative atom, the hydrogen atom will bear a partial positive charge, that is delta plus, as a result of induction. This partial positive charge, that is plus delta plus charge, can then interact with a lone pair from the electronegative atom of another molecule. So again repeating the answer, when hydrogen atom is connected to any electronegative atom. So first thing is hydrogen atom. Second thing, it should be connected to electronegative atom. Then if that is the case, that when hydrogen atom is connected to electronegative atom, hydrogen atom will bear plus delta charge due to induction. Thus delta plus charge can interact with a lone pair from another electronegative atom of other molecule. For example, let us take an example of water molecule. So this is the water molecule. Here hydrogen is connected to electronegative atom, that is oxygen. So hydrogen will develop plus delta charge. So this hydrogen can attract or can interact with lone pair of electron of other molecule. This is another molecule. So this hydrogen is interacting with lone pair of other molecule. So this is called, this dot dot dot, this is called hydrogen bond. The second example, ammonia. When hydrogen, this hydrogen is connected to electronegative element nitrogen, then this hydrogen develops a partial delta charge, positive delta charge. Now this hydrogen interacts with lone pair of electron of other molecule of ammonia, of nitrogen, and this bond between partial hydrogen and this will develop a negative delta charge. This nitrogen will develop a negative delta charge, and this bond, the dotted line, this is the bond formed, and this dotted line or this bond formed is called hydrogen bond. Now let us see the few questions. Why ethanol has higher boiling point than methoxymethane? Again, just think that ethanol is some organic compound and methoxymethane is another organic compound. We'll come to these compounds individually in later chapters. So first we draw the structure of ethanol and then we draw the extraction of methoxymethane. Both ethanol and methoxymethane have the same molecular formula. So if we write the molecular formula, it is C2 1 2 3 4 5 6 H6O. This is the molecular formula. Here also C2H6A. So both have same molecular formula. But ethanol have higher boiling point. This one having higher boiling point than methoxymethane, because ethanol experience intermolecular hydrogen bonding, giving rise to a very high boiling point. So here what happens, this hydrogen is connected to a electronegative element, that is oxygen. So here it develops a partial delta plus charge, which is capable to react or interact with another lone pair of electrons which is available. So here say this lone pair of electron is there for another molecule. Say if we draw another molecule of ethanol, it can be something like this. So here this lone pair of electron, it can interact and it will develop minus delta charge, and this bond is called H bond, hydrogen bond. So ethanol have hydrogen bonds, so intermolecular attraction is more in ethanol, and so the boiling point is of ethanol is more. But methoxymethane won't have hydrogen atom. Why it won't have? Because hydrogen bond. Why? Because this hydrogen, any of the hydrogen is not connected to any electronegative element, so it won't possess any hydrogen bond, methoxymethane, and its boiling and melting points are low. Let us see another question, that is trimethyl amine, ethyl methyl amine and propyl amine, all having the same molecular formula C3H9N but different boiling points. Explain. So the same answers. So you see this is trimethyl amine, this is ethyl methyl amine, and this is propyl amine. Here you can see the red hydrogen. It is connected to a electronegative element, that is nitrogen. Here two hydrogen atoms are connected to nitrogen, electronegative element nitrogen. So what we see, but in trimethylamine there is no hydrogen bond. So here there is a hydrogen bond and it possesses delta positive charge. Here there is a hydrogen bond and here there is a hydrogen bond. So the boiling point of propyl amine is more than that is highest out of these three. After propylamine, methylamine has the highest boiling point, and at last trimethylamine have the lowest boiling point. So trimethylamine does not exhibit any hydrogen bond and have a relatively low boiling point. Ethyl methylamine does exhibit hydrogen bond and therefore have higher boiling point. Finally, propylamine has two NH bond, that is hydrogen bond, and therefore exhibits more hydrogen bonding interaction, therefore having the highest boiling point. So let us move to the next topic. Next topic is fleeting dipole-dipole interaction. Sometimes we observe that compounds or hydrocarbons which are heavier have more higher boiling point. So we observe that in hydrocarbons boiling point increases with the increase in molecular weight. This can be explained by the concept of fleeting or transient dipole moment. To understand the source of these are temporary dipole moments. Okay, now, fleeting dipole-dipole interaction is the temporary one. Temporary dipole moments, we consider the electron to be in constant motion and therefore the center of negative charge is also constantly moving around the molecule. On average, the center of the negative charge coincides with the center of the positive charge, resulting a zero dipole moment. But at a given instant, the resulting of however, at a given instant, the center of negative charge and the center of positive charge might not coincide. The resulting transient dipole moment can then include a separate transient dipole moment in the neighbor molecule, initiating a fleeting attraction between the molecules. These attractive forces are called London dispersion force. London dispersion forces. So let me explain with the figure. So we consider here that electron is continuously moving, and many times it happens that electron and the positive nucleus comes, not nucleus, the electron and the positive charge comes align. So at that moment the dipole, there is no dipole moment is zero. But it is not the case that always it will happen, but while moving many time it will happen that they are not in line and some dipole interaction happens, and due to that interaction it develops positive and negative charges, partial positive and partial negative charges, and this therefore an attraction force is developed. This force is called London force. So in this case we can see here, due to movement of electrons, here it develops a partial negative charge, here it develops a partial positive charge, and the attraction between these two molecules are called London dispersion force. Now London dispersion force are stronger and higher molecular for higher molecular weight of hydrocarbon, because the compound having larger surface area and can accommodate more interaction. As a result, so London dispersion force are stronger with the higher molecular weight hydrocarbons, because it has larger surface area, and due to larger surface area it can accommodate more interaction. As a result, compounds of higher molecular weight will have higher boiling point. A branched hydrocarbon generally has a smaller surface area, and then the corresponding with respect to corresponding straight chain isomer, and therefore branching cause a decrease in boiling point. So remember two things. One, first, hydrocarbon with higher molecular weight will have higher London dispersion force, and again the isomers which are straight chain will have higher boiling point than that of the branch chain hydrocarbon, because the branch chain hydrocarbon will have less area for the same molecular formula. If it is one isomer is branched and one isomer is straight chain, the straight chain will have the more boiling point than that of the branch chain. Now let us see few questions based on this concept. Determine which compound has the higher boiling point, neopentane or 3-hexanol. So this is neopentane and this is hexanol, 3-hexanol. So here this is the structure. So from this structure, let us see the answer first, then I will explain. 3-hexanol will have higher boiling point because of the following reason. First reason is it has dipole moment, while 3-hexanol have dipole moments, while neopentane have no dipole moments. Why dipole moments? You see here, due to this oxygen, negativity of oxygen, so you can draw a dipole moment in this way. So it has the dipole moment, hexanol has the dipole moment, but neopentane won't have. First reason is this. Second reason, 3-hexanol will explain hydrogen bonding with neopentane, while neopentane does not. So it has hydrogen bonding also. Why? Because hydrogen is connected to a strongly electronegative element, that is oxygen. So it will develop partial positive charge, and this hydrogen is capable to interact with any lone pair of electron. So that will develop negative charge. So say here there is a lone pair of electron of an oxygen, then this will develop minus delta charge, and here the bond will form. This is the lone pair of electron. So here the bond will form, that is hydrogen bond. So second reason we have explained, it has hydrogen bond also, while no electronegative element is present in neopentane. And third is 3-hexanol is a in straight chain, whereas neopentane is in branch chain. So it has more surface space to interact, so it will possess more boiling point or melting point. So the third reason, 3-hexanol has 6 carbon atom and it is a straight chain, while neopentane has 5 carbon atom. In terms of carbon atom also, 3-hexanol is more, it has 6 carbon atom. So, and a second is it is in a straight chain while neopentane have 5 carbon atom, that is smaller in size and highly branched. Again it reduces the size. Due to these 4 reasons, 3-hexanol have higher boiling point than neopentane. So any of this type of question can be explained in terms of dipole moments, hydrogen bonding, London forces, etc. Any boiling and melting points questions. And one question is, more than one questions are will come in any of the question exams like IIT, JEE, NEET, any engineering college, even in class 12 to 11 exams. So let us see, this is very important topic. So this is homework. So homework you have to do without any help. Watch the video tutorial again and again, try to understand the concept and do the pause the video and do the homework. If still you find any difficulty, please drop a message in the message box of the video, will help you. So let us hope you do the problem sums. It will help you a lot. Let us move to the next question, next topic. Next topic is molecular representation. First is how we represent a molecule in pen and paper. So first is Lewis structure, second is partially condensed structures, third is condensed structure, and fourth is molecular formula. So let us see Lewis structure. First we'll go through Lewis structure. So Lewis structure is very easy. In Lewis structure, all the atoms and bonds are explicitly drawn. Lewis structure is only practical for smaller molecules. For example, Lewis structure for propanol is given by, so all the bonds are drawn, nothing we can lift. So this is Lewis structure. Second is partially condensed structure. So in this structure, carbon and hydrogen bond are not explicitly shown. For example, you see CH3 is not explicitly shown. CH3, this CH3, this CH3 are not explicitly shown. So this is partially condensed structure. So this is the structure for isopropanol. So one hint I am giving will come to nomenclature in future, but remember iso is for when same type of methyl group, this is called methyl group, CH3 is connected to a single carbon atom, that iso comes. All is the suffix we add for OH group, OH functional group. We'll come to functional group later on. So iso and propane, propane is for 3 carbon atom, 1, 2, 3. So propane. So isopropanol is the nomenclature of this compound. So third is condensed structure. Condensed structure, in condensed structure none of the bonds are drawn. So for example, same isopropanol is written as CH3 whole 2 CHOH. So no bonds are shown here. Now fourth is molecular formula. Here no structural informations are provided. Molecular formula, simply shows the number of each type of atom in a compound. There are, so it just shows the number. So for example, this is a molecular formula, C3H8O. So it doesn't gives any structural information. So there are actually 3 constitutional isomer with molecular formula C3H8O8 H8O. So first is so what are isomers? Constitutional isomer where molecular formula is same but the structural formula is different. So here C3H8O can be written as can be drawn as this structure, and its name is isopropanol. It can also be drawn as the same and the second structure, its name is propanol, and it can also be drawn in the third structure, that is ethyl methyl ether. Now let us see one question. Draw a Lewis structure for the following compound. For this compound, draw a Lewis structure. Step 1. Draw a partially condensed structure. First step. So for this, we will draw a partially condensed structure. So this structure can be written as this partially, where carbon and hydrogen bond will not be shown explicitly. So we have not shown this, we have not shown this, we have not shown this. 1, 2, 3, 4 carbon and hydrogen bonds are not shown. That is the first step. So from the given question, draw a partially condensed structure. When partially condensed structure is done, then from partially condensed structure, draw the CH bond. Draw all the CH bond. So here CH3, all the CH bond, this and this are drawn. Similarly, in all here also we have expanded the bond and drawn all the CH bond. So we got this structure. So this is the Lewis structure for the given question. Now for homework, I have given few questions. Draw the Lewis structure for each of the following compounds. Same way, follow that example and do it. The questions are very simple. Just try it on your own. If you have any problem, please write down in the message box. Second question, third question, please try it. Fourth question. So the thing which is written in yellow is very important. For solution, please write a comment in the message box. So viewers, students who have not subscribed our channel, please subscribe it, and please give a like sign if you like the video. And please share this channel with your friends and relatives so that they can also get help of this video. The next topic is bond line structure. So it is not practical to draw Lewis structure for large compound. For example, Lewis structure will be very complex for amoxicillin. Therefore, we draw bond line structure for such large compound. It simplifies the drawing process and also makes easy to read. For example, bond line structure for amoxicillin is given below. So it is a complex compound, but how easily we can represent it. So it has two benefits. One, it is easy to draw, and second, it is readable. Second topic is how to read bond line structure. So bond line structure are drawn in a zigzag format where each corner or endpoint represents a carbon atom. For example, each of the following structure has 6 carbon atoms. I have numbered it. So each endpoint or each corner have a 1 carbon atom. Second, double bonds are shown with 2 lines as usual, and triple bonds are shown with 3 lines. Triple bonds are drawn linear due to sp hybridized carbon atom. So remember that triple, in the last session, in the last class we have done, in the last video we have done that triple bond are always linear in shape and contains sp hybridized carbon atom. So triple bonds here will also, here it will be also linear. So double bonds are represented as 2 line, triple bonds are represented as triple line, and structure will be linear. Third is hydrogen atom bond to the carbon are also not shown in the bond line structure, because it assumes that each carbon atom will possess enough hydrogen atom so as to achieve the total of 4 bonds. So no hydrogen atoms are shown. For example, bond line structure for Lewis structure of this compound, so all the hydrogen atoms are not shown here, without hydrogen atom, and in the corners at the endpoints we consider the carbon atoms. That's it. So here please do this homework. Again, the yellow lines are very important. After trying, if you don't understand or if you don't know any question, please write on the message box. We'll help you. So here plus, please try to do these problems. So it was very fast. Let me move slowly so that you can pause the video and do the sums. Otherwise it will be difficult to pause. So here is the homework. So I am moving slowly so that you can pause the video and do the sums one by one. So this is question number 2. Question number 3, and the yellow lines are very important. Please follow up. Next topic is how to draw a bond line structure. First step is carbon atoms in the straight lines should be drawn in zigzag. So we'll draw it in zigzag. Second, when showing the double bonds, draw all the bonds as far apart as possible. So this is the good way to represent, not this one. So here they are very nearer. This double bond is very nearer to this. No, keep it apart, keep it far. So this angle should be more than this angle. So try to follow this one. Third one is when drawing a single bond, the direction in which the bonds are drawn is irrelevant. So it is irrelevant, either you draw this or this, both are same. The above two drawings are not representing the constitutional isomer. They are the two different drawings of same compounds. That's it. And last point is all heteroatoms, means atoms other than carbon and hydrogen, must be drawn, and any hydrogen atom attached to heteroatom also be drawn. So for example, this is heteroatom, that is OH, so it should be written, OH should be written, and we can't escape this hydrogen of heteroatom, we have to write it. So let us see one of the example. Draw a bond line structure of the following compound. So first step is remove all the hydrogen atom except those connected to heteroatoms. So this is the structure, this is the question here, and we have removed all the hydrogen atom except of heteroatoms. For example, we have not removed hydrogen for OH. Next is step 2 is place the carbon skeleton in a zigzag arrangement, but triple bond are drawn linear. So we have put, this was a straight, this is zigzag, but we keep triple bond as a straight structure. Now finally delete all the carbon atoms. So till here we have copied this one, and finally we delete all the carbon atom. So we got a bond line structure. Homework, this is again a homework. So yeah, these questions are given to you. Please draw the bond line structure. If any problem, please write a note on the message box. Identifying the functional group. So a functional group is a characteristic group of atoms or bonds that poses a predictable chemical behavior. For example, in the below reaction, the starting material has a carbon-carbon double bond, this one. So which is a functional group. So if it reacts with hydrogen in presence of platinum catalyst, then it gives the double bond is removed here. Similarly, if we see the next, here also you have a double bond. It reacts with hydrogen in presence of platinum catalyst. Here also double bond is removed. So it reacts in the same way, same manner. The chemistry of every organic compound is determined by the functional group present in the compound. Therefore, classification of organic compound is based on the functional group. For example, compounds with carbon-carbon double bond are classified as alkenes, while compounds possessing an OH group is classified as alcohols. Examples of common functional groups. So first is RX. X is where X is a halogen group. Halogen, it can be chlorine, it can be bromine, or it can be iodine. It is named as alkyl halides. So for methyl, it will be and halide is, if alkyl is methyl and halide is chloride, then it will be methyl chloride. If alkyl is ethyl and halide is bromine, then it will be ethyl bromide. In our example, alkyl is propyl, so N-propyl, and chloride halide is chlorine, so N-propyl chloride. N-propyl chloride. Here a double bonded carbon atom, so red, all the red are denoted as functional group. So double bond, so alkene. Name example is butene. Butene. Next is triple bond is alkyne. Our example is 1-butene. Our OH, that is alcohol. Our example is 1-butanol. O, that is ether. Our example is diethyl ether. So methyl SH group thiol. Our example is butane thiol. SR is sulfite. Our example is diethyl sulfite. Aromatic or arene. Our example is methyl benzene. Now ROR, that is ketone. Our examples 2-butane, 2-butane 1. Next is RCHO group, that is aldehyde, that is butanal. Our example. Carboxylic acid RCOOH, that is carboxylic acid. This, and it is named as, its name is pentanoic acid. pentanoic acid. TENOIC ACID acid, pentanoic acid. Next, ROX, that is acyl halide. Our example is acetyl chloride. Now next is anhydride. Our example is acetic anhydride. Next is ester. Red is, all the red is marked as the functional group. So our example is ethyl acetate. Next is amide. Our example is butanamide. And last is amine. Our example is diethylamine. And this is the end of today's session. Please subscribe, like and share our channel. Please click on the subscribe button to support us, and also click on the bell icon to get automatic notification whenever any video is uploaded by us. If you like the video, please give us a like, comment and write in the message box wherever you have difficulties in the exercise for the homework we have given. We'll help you in solving the exercise wherever you have problem. And thank you for your support and watching our videos. Please try to share this video to many students so that they can get help from these videos. Thank you very much.